Hello everyone, this is Prashanth. I am going to explain here in this session logical design of IoT. So first we have to enter into that logical design of IoT. First we have to recall all those topics which I explained in the previous session. So before logical design of IoT, in the previous session I have explained physical design of IoT. So in the physical design of IoT, mainly it having two topics. One is the things in IoT, and IoT protocols. So these are the two sessions, two things we discussed in the previous sessions. So things in IoT and IoT protocols. So IoT protocols means we have, as per OSI reference model, we have 7 layers, but in our IoT, I have explained only 4 types of layer, that is data link layer, network layer, application layer, session layer, like that. So in that, every network layer having different protocols to build the smart world. So these are the things I discussed in the previous session. So now I move on to the logical design of IoT here. So basically logical design of IoT having, it plays some logical expression as a logical expression to the apply on logical design of IoT on the devices. So here mainly logical design of IoT consisting 3 types of blocks here: IoT functional blocks, IoT communication model, and IoT communication APIs. So these are the 3 very important logical design of IoT. So logical design of IoT system refers to an abstract representation of the entities and process. So without going into the low level specific of the implementation. So basically it having 3 types of blocks: IoT functional blocks. So IoT functional blocks means what? The basic block diagram are the basic blocks of IoT device. So here after device, so this deals with the device specifications or device blocks inside the IoT device. Then after IoT device, then we move to the process the data by using some communication models. We have different 4 types of communication models. Now we explain further, and along with communication APIs, application program interface. So these are the 3 logical design of IoT. Let's move on to the first type of logical design of IoT, that is IoT functional block. So the IoT device basically having different types of specifications, different types of blocks it having. So the blocks are application, services, communication device, and security. Which type of protocols it, which type of security it can provide for us. Next to management, how can it can manage all the things in the IoT device. So here it provides the system the capability of identification, sensing, actuation, communication, and management. So basically IoT communication blocks, it provide the system capability. So what are the capability? Includes identification, sensing, actuation, communication, and management. Next, device. So device IoT system comprises of devices that provides sensing, actuation, monitoring, and control functions. Next, communication. So which type of communication it provide, or which type of communication it develop to process the data from one device to another device it can. So it handle the communication for IoT device by using different communication technologies, like whatever available in the market it can use. So this is the communication main blocks. So application, services, which type of services it can provide for us, which type of communication technology it can use to process the data from one device to another device, which type of devices it can be used, which type of security protocol it can provide for us. Next, how the entire system it can manage. So this is the basic block diagram of IoT device. So what services? So I already told which type of services: device monitoring, device control services, data publishing services, and services for device discovery. So these are the services it can provide for us. Next, management. So which type of things it can manage? It provide various functions to govern the whole IoT system, the particular network. Next, security. Which type of security services it can provide for us? Say secure IoT system, proximity functions such as authentication, authorization, message and context integrity, and data security. So these are the some security concern it can provide for us. Next, last one, application. So IoT application provide an interface that the users can use the control and monitor various aspects of the IoT system. So these are the functional blocks of IoT device: application, services, communication, device, security, and management. So next, move on to this is the diagram for elaboration of IoT functional blocks. So here, application. So it is IoT business process management, business process modeling, and business process execution. So in terms of virtual entity, so here virtual entity and IoT services. In terms of virtual entity, it provides VE resolution, VE service, VE and IoT service monitoring. So this is diagram to elaborate the IoT functional block. So this is the basic block diagram. So this is elaboration of that particular diagram. So security, authorization, key exchange and management, trust and reputation, identity management, and authentication. Next, management, configuration, fault, how the performance of device can be calculated. Next, member and state, either in lifetime member or temporary member, like that it can calculate. So communication protocols, routing and gateways, routing and addressing, error detection and correction codes, energy optimization, flow control, reliability, and quality of service. So this is the elaboration of IoT functional block, including application, security, communication, management, like that. So next, move on to the IoT communication models. It is very, very important to know. Basically, we have 4 types of communication models, including request response communication model, publish subscribe communication model, push-pull communication model, exclusive pair communication model. So these are the IoT communication models, very, very important to know to design any network or any device. So let's start with the first communication model, that is request response communication model. Request response. First, this is the basic first type of communication model, request response communication model. So here the 2 words are request and response. First, I am going to request something. For example, www.iare.ac.in. So this is the website www.iare.ac.in. I can type in the URL, then press enter. So I am requesting to the server to open the website of IARE. So I am requesting, I am sending through the URL. So immediately the response can receive the request. It can respond. It give response to the particular website. So here, request to response is a communication model in which the client sends a request to the server. Server responds to the request. So when the server receives a request, it decides how to respond within a short of time. Fetches the data, retrieves the resource representation, prepares the response, and then sends the response to the client. So this is basic level of communication model, request to response communication model. So here the communication is going on in between 2 things here, client and server. Client and server. The client can send the request to the server. The server immediately takes the request from the client and fetch the data. It response immediately to the particular request. So this is the communication is going on in between client and server. So here this is the client block diagram of request response communication model. Sends request to the server, request has been sent, the server receives request from the client, process request, looks up, fetches the resources, prepare response and sends the response to the client. So no intermediate devices involved in this process. So only the communication is going on in between client and server. So this is the resources. The resources can fetched by server. So this is the first type of communication model of IoT, request to response communication model. So I already told. So here the communication is going on in between two things here. One is the client, second one is the server. Client send the request, server can send again response to the client. So next move on to the second type of communication model, that is publish subscribe communication model. So here the one intermediary will available in this communication model, that is broker or intermediate person. So here publish subscribe are a communication model that involves publishers, brokers and consumers. So here the communication is going on in among three parameters here: publishers, brokers and consumers. Publishers are the source of data. Publishers send the data to the topics which are managed by the brokers. Publishers are not sent to the consumer. First, the consumer subscribe to the topics which are managed by the broker only. So it is the intermediate way. So the consumers directly not contact to the publisher. First, the publisher can send the data to the broker. So the broker can distribute the data to the consumer. So here in this diagram here, sends messages to the topics, that is topic 1 and topic 2. Message published by topic 1, message published to topic 2. So here subscriber 1, 2 for topic 1, consumer 3 for topic 3. So this is the way of data processing from publisher to the consumer in publisher subscribe communication model through the intermediate person, that is broker. So this is the second way of communication model in IoT, publish subscribe communication model. So the communication is going on among the three parameters here: publishers, brokers and consumers. Next, move on to the third type of communication model here, push-pull communication model. So here the data is moving in the form of queues here. So the push-pull is a communication model in which the data producers push the data to queues and consumers pull the data, push and pull. So here the data will pull and the data will push. Queues procedure do not need to be aware of the consumers. The queues also act as a buffer which helps to in situations when there is a mismatch between the rate at which the producers push the data, the rate at which the consumers pull the data. The queues help in decoupling the message between the producers and consumers. So here this is the publishers sends message to the queues. After that we have consumers. So this is the complete block diagram of push-pull communication model. So here the data producer can push the data consumer can pull up the data. So this is the third type of communication model, that is push-pull. The last type of communication model is exclusive pair communication model here. So exclusive pair communication model is a bidirectional way. Bidirectional full duplicate communication model it follows. So bidirectional means what? It can send, it can receive the data. That means two-way communication it follows. So bidirectional full duplex communication model that uses a persistent connection between the client and the server. Once the connection is set up, remains open until the client sends a request to the close to the connection. Client and server can send message to each other after connection setup is over. So this is client, this is the server. request to set up a connection, response accept the request, message from the server to client, connection close request, connection close response. So these are the way of communication going between client and server in exclusive pair communication model. So these are the 4 types of communication models available in IoT: request to response communication model, push-pull communication model, publish subscribe communication model, exclusive pair communication model. So these are the very important communication model in order to build some networks through the IoT. So next move on to the IoT communication APIs. Here we have 2 types of communication APIs, REST-based communication APIs and Websocket-based communication APIs. So let's move on to the first type of communication API. So before REST-based communication APIs, first we have to know what is API. Application Program Interface. The API stands for Application Program Interface. So what is API? API is a set of routines, protocols and tools for building software applications. Basically, the API stands for Application Program Interface. So it is a set of routines, protocols and tools to build software applications. In one word, it is the backbone of software application is nothing but backbone of software application. So the API specifies how the software components should interact, and the API should be used when programming graphical user interface components. A good API makes it easier to develop a program by providing all the building blocks. In order to build software components or software application, we can use suitable API components. Next, REST, which typically runs over HTTP, is often used to mobile applications, social websites, mashup tools and automated business process. Flexibility is provided by accessing resources their own unique universal resource identifier. So this is about the just few points regarding API. What is API? What is the functions of API? Let's move on to the first type of communication API, that is REST-based communication API. Very important communication API in IoT. REST-based communication API. So REST stands for Representational State Transfer. Basically, REST is a representational state transfer, is a set of architectural principles by which you can design web services and web APIs that focus on a system's resources and how resources states are addressed and transferred. Basically, REST stands for Representational State Transfer. It is a set of different components and different things, architectural principles by which you given web services and web APIs. REST APIs follows the request response communication model. So before that, we have discussed communication models. So each and every communication model, either request response communication model, publish subscribe communication model, push-pull communication model, exclusive communication model. So among the 4 communication models can be used by communication APIs. So the communication APIs can build up along with the communication models. So that means each and every communication API can use communication model. So here REST-based communication API can follow the request response communication model. Communication API can use communication model among 4. REST architectural constraints apply to the components, connections and elements within a distributed hypermedia system. So this is basic block diagram of communication REST-based communication API. So we already know it follows request to response communication model. That means we have to send the request. then we have to receive the response from the server. The communication is going on in between two things, client and server. So in REST-based communication API, same process will follow. So here HTTP client, it is REST aware HTTP client. Then HTTP packet. So in that HTTP command available, HTTP commands get, put, post and delete. Then REST payload, JSON and XML. Next HTTP server, authorization, and the server can do RESTful web services. So from these resources it can fetch the data and it can send back to the response to the client. So this is the basic block diagram of REST-based communication API. It follows request response communication model. Next, move on to the REST-based communication API's constraints. So here we have different types of constraints of REST-based communication API, that is client server. So we already know it follows request response communication model. So the communication is going on in between these two client and server. This is one of the constraints of REST architectural constraints. Next, stateless, cacheable, layered system, uniform interface, code on demand. Just we can elaborate these words in some other words. So the client server. So here the principle behind the client server constraint is the separation of concern. Separation allows client and server to be independently developed and updated. So this is the word belongs to client server. Next, stateless. What is stateless? Each request from the client to server must contain all the information necessary to understand the request and cannot take advantage of any stored context on the server. This is about stateless. Next, cacheable. Cache constraint requires the data within a response to a request be implicitly or explicitly labeled as cacheable or non-cacheable system. So if a response is cacheable, then the client cache is given to the right to use that response data for later equivalent request. So that is depends on either the request is correct or not, either cacheable or non-cacheable. So this is about the third constraint, that is cacheable. Next, layered system. What is layered system? Constrains the behavior of components such that each component cannot be seen beyond the immediate layer with which they are interacting. Uniform interface. So uniform interface means only single interface with the device. So uniform interface constraints require that method of communication between client and server must be uniform. Client and server can be uniform means, that's why we use request to response communication model. That is about uniform interface. So resources are identified in the request and are themselves is separated from the representation of the resources data turned to the client. Next, code on demand. So the server can provide executable code or script for client to execute in their context. The constraint is that only one that is optional. So these are the constraints of REST-based communication APIs: client server, stateless, cacheable, layered system, uniform interface, and code on demand. So next, move on to the some request response model by REST protocol. So REST is a full web service, is a collection of resources which are represented by URIs. RESTful web APIs has URL. So for example, like that. So here, this is the client, this is the server. In the server, we have different HTTP request codes, that is get, put, update or delete with payload, JSON and XML. Same response from the server, again request to the payload by using some methods, get, put, update, delete, like that. Finally, we got the response from the server. So this is the way of request response model used by the REST protocol, REST model. So these are the some HTTP request methods and actions here: get, head, put, post, delete, trace, connect, and options. What is get? Request to read a web page. Request to read a web page. For example, www.iare.ac.in. So when I type this website in the URL, so immediately it open homepage of website. So that is the homepage we have to read. That means request sent to the server. Immediately we got some data in terms of response, that is home page. That is request to read a web page. Next to head, request to read a web page's header. Request to store a web page, that is put. That means we have to add some data. Next to post, to append a web page, that is post to update the data. Next to remove, if you want to remove any constraint in that particular web page, we use delete method or delete code. Next to trace, echo the incoming request, we have to trace the particular request, we use trace method. Next to connect, reserved for future use. Options, query options, it can elaborate by using options method. So these are the different HTTP methods we use for our as per our requirement. Next, move on to the Websocket based communication APIs. So we have two types of APIs: REST based communication APIs and Websocket communication APIs. So REST based communication APIs we already over. It follows request response communication model. So every communication APIs follow particular communication model. So for example, REST based communication APIs follow request response communication model. So here Websocket communication APIs allows bidirectional full duplex communication between the server and client. Bidirectional means what? We already know. It can send, it can receive. It can send the request, it can receive the request in terms of some parameters. So Websocket communication follows exclusive pair communication model. So here REST will follow request response, Websocket communication model exclusive pair communication model. Communication API can use communication model. So here Websocket communication API, it can use exclusive pair communication model. So here in exclusive pair communication model, so same the block diagram will follow exclusive pair communication model. So here it is a client, it is a server. It can request set up a work Websocket connection. Request send, response can send again. These are the two initial handshake over HTTP. So remaining 4, data frame. These 4 are bidirectional communication over persistent Websocket connection. So remaining 2, it is a close request and close response. That is closing connection in between client and server. So this is Websocket based communication APIs. It depends the exclusive pair communication model. So the communication is going on in between two things here. One is the client, second one is the server. So this is about Websocket communication APIs. Next, what are the advantages of Websocket communication API? So here we have bidirectional, full duplex, single TCP connection. So bidirectional we already know. HTTP is a unidirectional protocol where the client always initiates a request, the server processes and returns a response, and then the client consumes it. So it is bidirectional, not unidirectional. So full duplex. HTTP allows the request message to go from the client and the server. Then the server sends a response to the message to the client. At a given time, either the client is taking to the server or server is taking to the client. Last, single TCP connection. is initiated for HTTP request and terminated after the response is received. A new TCP connection needs to be established for another HTTP request or response. So these are the three types of advantages of WebSocket: bidirectional, full duplex, and single TCP connection. Next, what are the differences between REST-based communication APIs and WebSocket communication API? So differences are important to know. So this is the REST, this is the WebSocket. We already know REST means representational state transfer. So it supports request response communication model. So the first to communicate, it supports which type of communication model? It supports request response communication model. It supports exclusive pair communication model. So this is the first difference. Next, it supports stateless protocol. It supports stateful protocol. Next, it supports unidirectional communication between the client and server. So here we have only two things, client and server. So between that we supposed only unidirectional. But in WebSocket, it supports bidirectional communication between the client and server. That is, client and server both can request to the server, request to each other. It can send, it can receive. It can send, it can receive. Server can receive, server can send. Client can send, client can receive. So that is the bidirectional way which is supported by WebSocket communication APIs. Next, it is a half duplex, it is a full duplex. It uses multiple TCP connection for each server over HTTP. It uses single TCP connection for each search over HTTP. Since it does not store the request response, so each time it needs to provide all the information while creating communication with server. For this reason, header overhead increases. Next, header overhead is very less compared to REST. Next, the last one, it supports both horizontal and vertical scalability. Vertical scaling is easier than horizontal scaling. So to implement this, we face some little bit complexity. That's why facing only vertical scaling is easier when WebSocket. So these are the differences between REST-based and WebSocket communication APIs. So it is very, very important to know in terms of communication model, in terms of stateful protocols, in terms of directional, by either unidirectional or bidirectional, and either it is full duplex or half duplex, in terms of TCP connection and header overhead issues, and whether it is supposed with vertical scaling or horizontal scaling. So these are the 7 differences between REST and WebSocket communication APIs. So these are the references I preferred for this session, the first, second and third references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.